In the previous video, when we were looking at stars, we were talking about the fact that sometimes the size gets a bit too large to be able to distinguish detail all that easily, and it makes it very difficult to talk about distances in that sort of sense too. And so as a result, we'll look now at astronomical distances and how we can make measurements a little bit easier to sort of compare, not necessarily to grasp how big they are, but basically it allows us to represent distances in a way that's a little bit more easy to compare them, and as a result it means that we don't need to use really large powers of 10 for distances in SI units. Instead, as I said, it allows to get a bit of a feel for relative distance, and to do that a range of alternative distance measurements used, and we'll have a look at what they are and their definitions. And in order to make sense of these, the definitions are useful, but ultimately in the end it's about, like I say, the relative measurements between, say, comparing certain distance measurements. So the first one that we're going to look at is the light year. You might have heard of this one before. Despite the way that the name sounds, it's not a measurement of time, it's a measurement of distance. The definition for a light year is that it's the distance travelled by light in 1 year. Note that if we're talking about light years, we can also talk about other similar units of measurement, so we could talk about light minutes or light seconds, but those sort of distances are not all that long, relatively speaking. And so light years are the ones that we talk about when we're looking at distances to other stars or other exoplanets or solar systems, those sorts of things. Just a bit of a reference here too, the light actually takes about 8 minutes to travel from the Sun to Earth, so that would mean that the distance from the Sun to Earth would be 8 light minutes. Now if we look at it in terms of quantities, 1 light year, if you went through and multiplied the speed of light by the number of seconds in a year, you would find that that distance comes out to be 9.46 by 10 to the 15 meters. Now I don't know about you, but my mind can't really fathom that distance, 9.46 by 10 to the 15 meters. I can't really visualize how big that is, but I can imagine the large distance that light would travel in 1 year. So 1 light year being a fairly large distance. The second one that we'll look at is the astronomical unit. Astronomical unit. The symbol that we use for the astronomical unit is capital A, capital U, and this one is fairly straightforward. It's the average distance between the Sun and the Earth. So if you were to look at the orbit of the Earth, it's not exactly circular, it's a little bit elliptical. So if you take the average distance, you would get the quantity of 1 astronomical unit, and 1 astronomical unit is equal to 1.50 by 10 to the 11. So you can see there that it's a fair bit shorter than a light year, so by 10 to the 4 times shorter, and therefore not quite as useful when you're talking about longer distances. If you're looking at, say, distances across the solar system, or potentially the distance of an exoplanet around the star that it's orbiting, you might talk in astronomical units, so you can relate it back to the distance from the Sun to the Earth. Now the last one's a little bit strange. We'll need to sort of state it first, and then we'll go into the next bit of content that will help to explain what a parsec is. So a parsec, the definition is that it's the distance of which 1 astronomical unit subtends an angle of 1 arcsecond. Now that idea of 1 arcsecond, if you take 1 degree and then divide it into 60 parts, that would give you an arc minute, and take that arc minute and divide it into 60 parts again, you get an arc second. So an arc second is 1/60th of 1/60th of 1 second, of 1 degree, sorry. Or if you want to think of it just as a fraction, it'd be 1/3600th of 1 degree. Now, like I said, we'll talk a little bit more about that when we start looking at stellar parallax, but just wanted to mention the definition there. If you then convert that to a distance measurement, 1 parsec is equal to 3.26 light years, and that's equal to 3.09 by 10 to the 16 meters. Now, in the data booklet, you'll notice that I've highlighted those previous conversions. The data booklet only has the first part of that conversion there, so 1 parsec being equal to 3.26 light years. So if you wanted to figure out what that distance was, you can then convert the light years into meters using the conversion above. Quite often too, the distances in when you're looking at fairly distant objects, instead of talking about parsecs, you might talk about kiloparsecs. So that would be 1,000 parsecs. So just to mention that as we go through. Now, I have a feeling that the next little bit on stellar parallax is going to take a little bit longer than might fit into one video, so I'll do that in a separate video.